Hey, we're celebrating our last content, so I'm so excited for you. So now what we're going to do is we're going to take the washer method and we're going to take it off of the X and Y axis, but we are going to keep it to a vertical axis of rotation or a horizontal. I was asked yesterday, would we ever see anything that's you're rotating like on Y equals X? No, not in AP Calculus AB. I'm not even sure if they do that in a BC. So here's example 1, and both of these are calculator active. So grab your calculators. It says, suppose we have the region bounded by y equals the square root of x and y equals x. Find the volume of the region that is revolved around the line y equals -1. So I'm going to give you 2 or 3 minutes head start. What I'd like you to do is make a sketch. Determine the region, determine whether you have a vertical or horizontal axis of revolution. See if you can determine capital R and lowercase r. Then I'll start working. I personally like to know where my intersections will be. So that will give me x equals 0 and x equals 1. And I think we saw something similar to this. This is y equals the square root of x. This one is y equals x squared. And this one says we want to, oh, thank you. Oops, I was thinking of the one from yesterday, wasn't I? Okay, yeah, so that's going to make a difference. There we go. Thank you. So this is, yeah, so this will be y equals x. There we go. So I'm looking at this region here. And then here's -1, and I want to rotate this. So I'm doing slices that are going to be dx. All right, anybody want to try? What would capital R be? Logan?
Capital R is the square root of x plus 1.
Nice job. The square root of x plus 1. All right, and what about lowercase r? Kai, what'd you think? Yep, just x plus 1. So then the big idea here is to do the volume. It's pi on the x-axis, that's 0 to 1. You take capital R squared minus lowercase r squared dx. So on a free response question, you might be asked just to set it up and not solve. You might be asked to solve. They want to see this step here. This is going to be worth like at least 2 points because that indicates you knew capital R, lowercase r, you have the limits of integration. Then let's just do this one on our calculators. Remember to go at least 3 decimal places. What I'd recommend is if you're nervous about rounding or rounding incorrectly, go 4 decimal places and just stop. Not even rounding the 4, just truncate after 4, and that's fine. What are we getting?
0.5.
You got 0.5,
No,
Julian?
I got mine.
Okay, that's what I got. 1.571. That's what I got.
I forgot pipe and I keep on doing it.
Oh, okay. Yeah. All right, example 2. Consider the region bounded by x equals y squared, y equals x minus 2. Find the volume when the region is rotated about the line x equals 7. Use your calculator. So I'm going to give you 3-4 minutes. Make your sketch, determine the region, set up the integral, and use your calculator. Let's see how far you can get on this one. There is a little clue. Can you tell that this one is solved for x? That usually means you're going to need them in terms of y. Now, it's not true with the second equation, but that one's easily solved for x. But that is typically a clue that you need them in terms of y, solved for x. All right, so I'm starting this one. I found my points of intersection. So that was at 1, -1, and 4, 2. My axis of rotation, so remember this is, my slices will be perpendicular, so it's a dy. All right, here comes the most challenging part of this, is what would be capital R? Kai, what do you think? Yeah, 7 minus y squared. Because you're going all the way to the 7 and you're going to subtract off the y squared. Then how about lowercase r? Yeah, Dylan?
5 minus y squared, or 5 minus y.
Yeah. Can we?
It would start as 7 minus x minus plus 13.
Yeah, like this.
Start like that, yeah, and then go minus 5 minus y.
Yeah, there you go. Nice work. Okay. So then we've got y, or not y, volume equals pi times the integral. Okay, now I'm looking at the region, and my limits of integration are the y values in that region. So what are my limits of integration here? -1 to 2. So then you're going to take 7 minus y squared squared minus 5 minus y squared dy. I'm going to double check my answer doesn't look right. I'm going to check this one more time. There we go. All right, that looks a lot better. All right, what did you get?
152.61, but that seems too low.
You know, that's what I got the first time, but I've just entered it again, and I got 48.6.
Yeah, you forgot pi.
Oh, I did got the pi. Okay, yeah, so that's what I got. Okay, that just didn't seem right. 152.68. That's so funny. Okay. All right, that finishes up the notes. Video.